Let us try to identify the equation of a line in the form ax plus by plus c equals 0, or the usual general form of equation of a line, but this time using vectors. Of course, our given here is p 4 and 0 and q 3 negative 1. We already have a 2-point form in our high school years where we can determine the equation of a line using that form. But this time, since this is in connection with the concept of vectors here in analytical approaches to modern geometry, let's use the vectors. We know that the vector v is the direction vector of a line. In this case, if it passes through these 2 points, it could be in the form L is equal to P plus your direction vector V. Or you can use Q plus your direction vector V. They are just the same, or will have the same line referring to, because we have the same direction vector. So we are going to start with the direction vector first and continue with a process presented in one of the videos here in this playlist. Try to review that as we determine the equation of a line in the form ax plus by plus c using vectors. Now, but of course, to start, just to illustrate this further, let's plot these points on this Cartesian plane, considering that each grid is by 1. So you will have here p is at 4, 0, 1, 2, 3, 4. So our p is here. This is actually identified as 4 and 0. And your q is at 3 and 1. So you have here 1, 2, 3, and then you have here 1. So 3, sorry, negative 1, my bad. 3 and negative 1, so it's somewhere here. 3, that's our q. 3 and negative 1. So if I'm going to connect it with a certain line, hopefully my illustration is accurate. And of course, since it's a line, let me add here, okay, arrowheads. So this can be represented by this form, okay, or again the equation of a line in this form, okay. So let's try to use this process. Since the vector is not given, we can determine the vector, okay, by the process we have presented in the discussions in this series. So you have q minus p, you have 3, negative 1, minus your p, which is 4, and 0. So you have here 3, minus 4, negative 1, minus 0. So you'll have here negative 1 and negative 1. And since this is a direction vector, to differentiate that from in any point, let's use brackets. This is direction vector, and then since we already have this one, if you would like to stick to this, the equation of this line here, using p plus vector v, you could have here, using your p, L is equal to, you have your, let's have 4, 0, plus your direction vector negative 1 and negative 1. So this also, L is equal to 4, 0, plus your direction vector, so it should be bracket, direction vector negative 1, negative 1. Or you could even use q. They will have different forms, but this will become q. But since they have the same direction vector, let's just simply stick as to that. Okay. But since this is not our goal is again ax plus by plus c equal to 0. Let's continue further. We need to start with the vector, and since again the vector is not given earlier, that's why we solve for the vector. But this time, since the vector is given, let's start with the process here of identifying the normal vector first. The normal vector is identified as negative v sub 2 and v sub 1 of our direction vector. This is our v sub 1, this is our v sub 2. So our normal vector using that is the negative of negative 1, and then you have your v sub 1, which is negative 1. So your direction vector is positive 1 and negative 1. This is the normal vector, or the direction vector of the normal line. Okay, now with this, the next step here, actually identifying a and b coefficients intended for this form. Now a and b coefficients are just basically these values in your normal vector. Again, it should be in your normal vector, not the direction vector v. Or in this case, you can simply say a is this value, negative v sub 2, and your b is actually this value, v sub 1. So in this case, our a is positive 1 and your b is negative 1. So we're almost there. What we just need to identify next is the value of c to complete this form. But since c is dependent on what would be the combination of ax and by, since we already have a and b, we need the value of x and y. And which value are we referring to? Take note that both points, p and q, are on the same line. So we can use any of them as our x and y values. So let me use here, okay, our p, which is identified as 4, 0. It's always easier to use a certain value with 0 because later on it's easier to simplify that. That would mean this would be our x and that would be our y. So solving for c rather, ax plus by plus c is equal to 0. Our a is 1 times x being 4 plus negative b is b is negative 1 times y, which is 0, plus c is equal to 0. So solving for that, you have 4 plus 0, or simply 4 plus 0 plus c is equal to 0. With that, our c is actually negative 4. Okay? So since this is our c, negative 4, we can now determine, we now have rather a, b, and c coefficients. But to determine a more general form of ax plus by plus c, we need to pick appropriate, or we need to set x and y as arbitrary values. So it would actually describe for all. Okay? So that would mean we are just going to let our a, b, and c as it themselves and x and y as variables and that's themselves. By the way, what if you're asking, what if I were going to use q, which is 3 and negative 1? Do we get the same value of c here? So I'm gonna leave that to you, but to verify that. But of course, if you would like to use here, again, your a is 1. So for your ax plus by plus c, so you have your 1, your x is a 3 in this manner, plus your b is negative 1, right? This is your b, times negative 1, plus c is equal to 0. You have 3, that's positive 1, plus c is equal to 0. So you still have 4 plus c equal to 0. Your c is still negative 4. See that even you were going to use q or p, you will still get the value of c, because again, they are on the same line. Now, going back here to complete our process, so you have your a identified earlier as 1. So you have 1x, then plus negative 1y. Let me simplify it later on. Okay? Plus your negative 4 as your c is equal to 0. So simplifying that, you have x minus y minus 4 equal to 0. This is the form of, or this is the equation of a line passing through the points P and Q using vectors. So again, it is actually equal to x minus y. So you have x minus y, sorry, let me do it again. This is actually identified as here, x minus y minus 4 is equal to 0. This is its form of ax plus by plus c, and this is the form using the form using vectors, vector and a point, as discussed in this playlist as well. By the way, you can try solving on your own using, again, the 2-point form using your high school years. If you're not asked to use vectors, definitely you can use this form. Then you have your slope, okay? But if you are restricted to use vectors, basically you're going to follow what we did in this video. But if you're not restricted, then you can just simply use the 2-point form to determine whether the equation of a line will still be x minus y minus 4 equal to 0. Okay? We are actually presenting here the possibility of the 2-point form because our given was actually with 2 points. But what if the given is already the vector itself? So basically, you're going to follow the same process as this one here. Thank you very much for watching.